All right, we're going to do the parallel forces inquiry questions. In the first one, we have a meter stick. So it has 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on the 10 centimeter, there's an F1. And on the 90, there's an F2. And then 10, 20, 30, there's a 221 gram, because just the weight and also the clip. And then actually right here, there's also a clip. So we're going to have a 21 there. And then skip 2, and then we got right here, there's going to be 1,021. And then right here, there's going to be a 521. And then on the end, there's going to be a 21 gram. And then actually 1, 2, 3, 4, 5, right in the center, we have the mass of the meter stick, 92.8. It says in the problem. So a lot of people forget the mass of the meter stick that needs to always be on there. If you don't see something physically hanging on the stick, we forget that the stick has mass, and that should be right there in the middle. A lot of times students also forget the 21 grams because we think that somehow that it's part of the up force. It's not. It's just a clip that we put on the meter stick so that this scale can hook onto something. But that 21 gram clip is on the meter stick, and it's part of the mass. And so we're trying to figure out F1 and F2. And so what we want to do is we want to just, we don't really need to even do ups and downs here. F1, well, we can. Let's see, ups, downs. F1 is an up and F2 is a down. So, F1 is an up and F2 is both an up. So the downs are 21 plus 221 plus 92.8 plus 1,021 plus 521 plus 21. Those are all the down forces. That's 1898. We'll just round it off. Okay. So really what we need to do is we need to figure out one of these unknown forces. So when we have two unknown forces, that tells you where you want to put your reference point. I could either put it at F1 or F2. I'm going to go ahead and measure everything from the F1 point, which means I'm not going to worry about F1. And I'm not going to worry about the 21. I don't have to worry about those. I'm going to make sure the torques are all balanced around this. So all of these 1, 2, 3, 4, 5, all those 5 down forces are all going to be going, around this way, clockwise torques. And this one here is going to go around the other way. That's a counterclockwise torque. So really, I have F2 times 8, because it's 1, 2, 3, 4, 5, 6, 7, 8 over. And all that should equal all the down torques. So I'll do those real quick. I have 2 times 221 plus 1, 2, 3, 4 times 92.8 plus 5 times 1,021 plus 6 times 521, and then plus 8 times 21. So all of those are my counter or clockwise torques, and this is a counterclockwise torque, and they have to be equal to each other. So I can just do 2 times 221 plus 4 times 92.8 plus 5 times 1,021 plus 6 times 521 plus 8 times 21 equals, divide that by 8, and my F2 is 1152. So my F1, there's no reason to come over here and do a reference point here and do torques the other way when you have this chart right here. I can just take 1898 minus 1152, and my F1 is 746. So there's the two forces. And I didn't get that on the screen, did I? So that's too bad. So hopefully you can see what we did there, and got my torques, clockwise and counterclockwise torques, figure out what F2 was, and then I subtracted F2 from this to give me my F1. And that's that problem. All right, part 2, there's a bridge. a big bridge, and it's being supported by pillar A and pillar B. And the bridge, it says, is uniform. It's 200 meters long. So I'm just going to write a 200 up here. And the bridge is uniform, which means the weight of the bridge should be right in the middle. So right here in the middle is the weight, and it happens to be 4 E5 newtons, 400,000 newtons. So that from out to there would be 100. The truck, there's a truck on here that's driving on here, and it is 80 meters from pillar B, and the truck weighs 3,000 newtons. And we're trying to just simply find what's A and B. So again, ups and downs. Total down is 403,000 newtons. That's the truck and the bridge added up. And the ups are A and B. So A plus B needs to equal 403,000. A and B you can't just take 403,000 and divide it by 2 because the truck is skewed over this way a little bit. The weight is, the bridge is evenly distributed. In fact, if the truck drives up a little bit and gets right here on this point, then you could take 403,000 divided by 2, and that would be each of those. But in this case, B should be a little heavier than A. So I'm going to measure from B, and I'm going to do the torque. So 80 times 3,000 would be a counterclockwise. So 80 times 3,000. And then I'm going to add on plus 100 times 400,000. That'd be another counterclockwise. That should equal all the way over 200 times A. That's going to be a clockwise. So 200 times A. And then I can just solve it. 80 times 3,000 plus 100 times 4E5 equals, divide by 200. And for A, I get 201, 200 newtons. And then I subtract that from the 403,000, and I should get a B, which would be 201,800 newtons, which is basically 600 newtons more as would be at B. And that's how you solve that problem. Pretty easy, I think.